Hello, today we're going to be going over the problem blocked Billboard 2 in the 2018 January Bronze Contest. So a brief overview of the problem is that there are two billboards that Bessie can look at. The first billboard has or advertises something that Bessie does not want to look at, and the second one, which is in front of the, we'll just call it the bad billboard, is advertising that something Bessie does like to look at. So we're basically going to try to find the amount of tarp Bessie needs to use to cover the billboard that Bessie does not want to look at. So to visualize, let's say this is the billboard that Bessie does not want to look at. Or sorry, we can use a different color. So we'll call this the bad billboard, or the billboard that Bessie does not want to look at. And then we'll call this this will be the billboard that Bessie does want to look at. So call this the good one. And so in this case, we would need this much tarp to cover the billboard that Bessie does not want to look at, as this area right here is covered by the good billboard. And so yeah, the problem is just we're trying to find the minimal area of tarp needed. So for this problem, we're going to be looking at a few, I guess, cases of how the billboards could be set up. The first case is when the x coordinates of the good billboard are, I'll call them, I guess, wider than the bad billboard. So this is a case of that where if we call this AX1, AX2, BX1, you can see that AX1 is smaller than BX1, but oh sorry, this should be 2. AX2 is larger than BX2, so yeah, that's going to be the first case. The second case is this basically the same thing, but for y coordinates. So if this is AY1 is greater than BY1, but AY2 is smaller than BY2. So the third case is going to be when we don't have the good billboard being wider in the x dimension or the y dimension than the bad billboard. That basically means that it's going to look something like this. So as you can see here, if we call this the x length is not, I guess, wider than the x length of the bad billboard, and the same goes for the y length of the good billboard and the bad billboard. So since we can't have a tarp that is not in a rectangular shape, so we can't have one like looking like this, we'd need to cover the entire billboard, even though this area is covered by, because obviously the tarp can't be shaped in like this. And the fourth major case is when the good billboard is just overlapping the entire bad billboard. And so in this case we would not need any tarp to cover it up. And yeah, if we take a look at the sample input, so as you can see here, so this would be, in terms of x, this would be 5, -1, this would be 10, and 3. And then for, oh yeah, and they give the coordinates to the bad billboard first, so we'd have one at 2, 1, and then 7. Oh, go ahead. Oh, oops. So it's going to be looking something like this. Oh. Yeah, so this would be part of the third case, because even though we got this, all this area covered by the good billboard, we can't have a tarp shaped like this. So we're going to need to cover the entire bad billboard with tarp. And so yeah, that's basically the solution to the problem. So we'll just get going. So first we'll just define some variables and arrays. Oh, actually. Okay. So we're just going to be storing our coordinates in these two arrays. So the A array will have all of the coordinates of the good billboard, which will be inputted second, and then the B array will take in the coordinates of the bad billboard. Total is just going to be the answer. Actually, second thought we already have. Yeah, we actually don't need that because we have this one here. X side will be the X length of the tarp needed, and the Y will be the Y length of the tarp needed, and area will just be the answer. Actually, yeah, so here we're just taking in the input. Okay, so we're going to be looking at our first case first. And of the first case where the x coordinates of the good billboard are overlapping that of the y billboard, and yeah, actually, let me just clarify. So what I mean by overlapping is that, let's say these are the x coordinates of the good billboard, then these are the x coordinates of the bad billboard, and you can see that this one is greater than this one. Sorry, this one is less than this one, and this one is greater than this one. So yeah, I wouldn't say that's exactly overlapping, but I can't think of a better word. And the same thing would go for the y coordinates. So these are the y coordinates of the good one. These are the ones of the bad one. Then we'll just call them overlapping, for lack of a better word. Yeah, so and of the first x overlapping case, and yeah, this is just checking if it is overlapping, as in like the first coordinate is less than the first coordinate of the bad billboard, and the second coordinate of the good billboard is greater than that of the bad billboard. And then we're going to have to check if VA3. So basically what this is saying right here is that, let's just say we have the, just say we have the good billboard right here. And we know that because of this, the x coordinates of the bad billboard will be in between these two. But what this is basically checking is that the y coordinates, you can either have a billboard that's like this or that's like this. And so this case is checking if checking for this type of billboard. Yeah, and so if this is the case, we'll just do so what we're going to do is we're going to take, I'll go back to my drawing. Basically what we're going to do here is that we will take, we're going to take this, which is the A1 minus B1. So this would be and then the x side would just be B of 0 and B of 2. Because the tarp we're going to need is just this. Yeah. And then what we're going to do is just do area is equal to the y side times x. And yeah, so for the second one, it's going to be basically the exact same, except this time we're going to check if it will be kind of below, so then we'll have 3 is actually less than this, and then we have 1 would be less than b. Yeah, so this case it's just and we'll just have to find the area of here. And yeah, so that'll be so the only thing that changes is the y side, because the x side will just be here and here, as this is the x overlapping case. So now we're going to go into when the y is overlapping. So first we'll check so this is just checking if the lower coordinate of the good one is less than the lower coordinate of the bad one, and if the upper coordinate of the good one is greater than that of the bad one. And then similar to what we just did up here, we're going to check, but instead of doing the y coordinates like we did here, we're going to just do the same thing for the x coordinates. So we can just do 0. Yeah, so the x coordinate, the smaller x coordinate is greater than that of the bad one, but smaller than that of the upper bad one, and then, or I'll just draw it out. So this is a good billboard. And then this would be the bad billboard. So we can see the oh wait, no, that would actually not be that. So the x coordinate here is greater than that right here, but smaller than the one right here. But then this one is also greater than that. So you see that in the logic right here. So this is the case. We'll just take the x coordinate difference. So wait, would that be right? No, it'd be a 0. Yeah, actually, and yeah, we'll just keep doing the same thing for the next case. So I'm just going to copy and paste this. This case. And then the next scenario is when, like we discussed about, it's over, some of the billboards are overlapping, but we can't really have a rectangular tarp to cover it, and we're just gonna have to cover the entire bad billboard, um, even if some of it is covered. So yeah, so here we just have to make sure that the billboards are actually overlapping in some way. Oh wait, my bad. Actually, right. Sorry, this is getting a little confusing. Right here. Okay, first we're gonna check if the entire thing is overlapping. So if the good billboard just completely covers a bad billboard, um, then we don't need any tarp for that. And in any other case that hasn't been covered by these if statements means that they're overlapping but not in a way that we can, shave off a portion, and we actually have to just cover the entire bad billboard because we can't have like a non-rectangular tarp. So in that case, it would just be the sides multiplied to each other of the bad billboard. And yeah, we can just print out the answer. Oh, I just realized the input. Output, sorry. It seems like we ran into a different error. Oh. See if this. Yeah, and also just a note. During the contest or just practicing, I would recommend running it on your compiler before submitting it, as you're gonna save a lot more time. I'm just doing it straight away just for the sake of the video. And yeah. So that is Locked Billboard 2. Thank you for watching.